Good day, grade 12s. Today, under technical mathematics, we have for today's lesson, okay, my name is Mr. Posa. Before we can start our lesson for today, I also want to advise learners that they must make sure that they have examination guideline for technical mathematics. You can get it from the DBE website. It's a very important document that one should have. Now let's see what we can find under this technical mathematics. Under content for grade 12, it's trigonometry, and then this topic, it contribute 50 plus or minus 3. And then under trigonometry, we have trig ratios, identities, and equations. Then we have trig functions. And the last one is 2D and 3D problems, right? But for today's lesson is going to be specifically on 2D problems. Then we are going to explain more into 3D problems. And you remember the 2D problems we have dealt with them, I think, last year in grade 11. So this year you were introduced to 3D problems. So we are going to be touching on that for today's lesson. All right, as you know that the problem, we have 2D problems, then we do have what 3D problems. And then for you to be able to solve 2D problems and 3D problems, to apply the sine and the cosine to solve problem in 2 and 3D dimension, the cosine rule. So it's very when to use the sine rule, when to use the cosine rule on 2D as well as on 3D. But this is going to be just a revision for us, because we have dealt with 2D when we're in grade 11. And then this year in grade 12, we were introduced to 3D problems, but we are still going to use the same approach when we are solving triangles under trigonometry. Now let's see what we are having. All right. Now I'm just going to explain different types of triangle that we are having, and then so that we can be able to know when to use the what we have discussed earlier on, the sine rule, the cosine rule, and the area rule. Now, let us try to look into these two triangles. The first one, you can see that we are having right angle triangle. We are having right angle triangle, and then under right angle triangle. So for instance, if you are being asked to calculate side or angle, then we're going to use the following formula. First, we're going to use what? We're going to use Pythagoras, or we can use trig ratios. Then you can see just next to this triangle, we have those trigonometry ratios, which is sine theta equals to y over r. And then we have cos theta equals to x over r. And then we have tan theta equals to y over x. Okay. Now, what will happen if you now having a triangle which is not a right angle triangle? Now, for you to be able to calculate, for instance, if they ask you to calculate a side, or you have to calculate an angle, then we have to use the following. One, the sine rule, the cosine rule, and the area rule, right? So that's what we are going to be focusing on for today's lesson. When to use the sine rule, when to use the cosine rule. And the last one, of course, then when if you have to calculate the area of a triangle, then we're going to use the area rule. Now let's proceed. Now there are conditions that one should remember before we can deal with any triangle where we have to solve problems, or when we have to solve the sides and the angle. Now first we have this one of sine rule. Now before we can use sine rule, we need to meet the following condition, meaning a triangle should have the following condition. First, given two sides and one angle that is not between the two given sides. All right? Meaning when you have a triangle and that triangle has two sides and one angle, and that angle must not be between the two given sides. Right? The second condition is given two angles and one side. Given two angles and one side. So if you come across a triangle where you are having two angles and one side, then you must know that in that case you are going to have the following condition. First, having all three sides. In a triangle that has all three sides, you just have to know that there you are going to use what? You are going to use a cosine rule. Okay? And then the last condition, it says, given two sides and one angle that is between the two given sides. Can you understand that one? We are given two sides and one angle, which is between the two given sides. So it's not the same as sine rule. Remember that one of sine rule, it says two sides, one angle, but this angle must not be between the two given sides. And then whereas for sine rule, the cosine rule, it says two sides and one angle that is between the two given sides, right? And then the last one where you have to calculate the area of a triangle, and then that triangle must have the following condition, which is given two sides and one angle that is between the two given sides. Can you see this condition is the same as this one of what? This one of cosine. So it's very important for you to understand all these conditions, so that by the time you have to answer any question, whether it's 2D or 3D, then you must be able to know which formula to use to calculate. All right, it's very important. My dear learners, please make sure that before you go and write paper 2, during trial or the final examination, make sure that you revise all these conditions. You must know all the formula that that we're going to use in order to calculate any question under trigonometry on 2D and 3D. Sine and cosine rule formula. All right, then first we can see that we're having a triangle, and next to the triangle is the formula that we are using when we are calculating the sine, using the sine rule per se, right? Then what is going to happen on this one? You can see that we are having small a divided by sine A equals to small b over sine B equals to small c over sine C. All right. Now you can write it in this way, or you can also write it in this way. So there's no problem either way. but make sure that it's small a divided by sine a, meaning this small a is the side. For instance, let me just show you something. We are referring to this angle, and then the side which is opposite to this angle there is going to be small a. The same applies with this C. If this C here, this angle of C, the opposite side of that is going to be small c. And then B, the same applies with B. If this angle of B, then the opposite side is going to be small b. So that's how you are going to obtain what? You're going to obtain the formula for sine rule. So it's very important, my dear learners, that to use the correct formula when you are calculating. But since we have touched on the condition to use what? To use the sine rule. The second one, we are having what? We are having the cosine rule. You can see that we're having a cosine rule. So this is the formula that we're using when we are calculating the sides or the angle. And when we are applying what? The cosine rule. Okay. And then let's proceed. Then we're going to use the sine rule or the area rule moving forward. Example 1, on to the problem. And then let's see what we're having and how do we answer the questions. The diagram below shows the two vertical poles, AD and BC. Can you see AD and BC? Point E lies on the same horizontal plane of pole AD and BC such that DE equals to EC equals to 8 meters. The angle of elevation of B from A is 22.5 degrees and B angle EC is 75 degrees. And then they are saying AD equals to 25 meter, and the last one is BC equal AB equals approximately 13 meter. Then how do we do that? Now, since we are in need of this side of AB, you can now check which side to use, which triangle to use. Now you can see that there's a triangle here where we have the elevation, angle of elevation which is 22.5, and therefore, and then what we're going to do now, you can see that AD is 25, and then we agree that from this point here to C is also 25, right? But now, since we are having length from BC, which is 30, then we are going to say 30 minus 25, then it's going to give us what? 5. So this is going to be 5. Then you can see that in this triangle AB and this point here, it's a right angle triangle. Then we can now use what? The trig ratio to calculate side AB, right? Then because now we are having this angle here, and then this side which is opposite, this side is going to be opposite of this angle here, which is 5. And then which trig ratio that we're going to use? Then we're going to use sine theta. Then you can see that this what we did. It's sine 22.5 equals to 5 over AB. Then what we're going to do, we're going to do cross multiply, and then this is what we're going to have. Then you just press your calculator, then you're going to get 13.066, and then the answer is going to be 13 meter. All right. Now the second question, determine the nearest meter, the length of BE. Where is BE? You can see here is BE, this side is BE. Then you can see we've got a triangle there, which is BCE. And then we have the length of BC, which is 30. We also have the angle there, which is what? 75. 75. So if we have that, then we can be able to calculate using the trig ratios, because now you can see that this triangle BCE is a right angle triangle because it has 90 degrees down there. Then we can now use what? The trig ratio. Now we're going to use the sine, because we know that if we're having this angle there, and then this side, which is 30, is opposite, and then this, the longest side there, we can see it's the hypotenuse. Then we're going to use the sine, the ratio of sine, and therefore, then we're going to substitute. Then after this, then we just cross multiply. Let's cross multiply. Then we're having BE equals to 30 over sine 75 degrees. All right. So that's how you should go about it. And then you just press your calculator there. The answer is 31,058 meter. But because the instruction says we should write to the nearest meter, then hence our answer is 31 meter. Our answer is 31 meter. So that's how you should go about it. You can see since now we've been using what? Trig ratios. So trig ratios are also very important because we have been dealing with what? Right angle triangle. And earlier on, I also try to emphasize on that point. If you are having a right angle triangle, then you must just know that you are going to be working with what? With trig ratios, right? Now let's see another problem. Let's see what we are having. All right. Now this one, it says the diagram below shows the position of the helicopter at point P, which is directly above D on the ground. Point S, D, and T lie in the same horizontal plane such that point S and T are equidistant. Meaning they are equal. Equidistant means equal from D, and then PD is equals to 70 meter, and then S angle DT equals to 117 degrees, and S angle PT equals to 32 degrees. Now let's try to calculate the following. Calculate the following: the distance SD. Let's go and find SD. This is the SD. Can you see SD there? SD. Now when you see SD, SD is the part of two triangles, which is PDS, and the other one is SDT, right? But which triangle to use for us to be able to calculate SD? Then we're going to use this triangle PDS. Why? Because you can see that we're having angle there, we're having a side there. Then it's not going to be possible for you to use this triangle of SDT because we only have what? We only have angle there. Then it's not going to be possible for us to calculate that side. And then let's see on how do we calculate that. Now, because this triangle PDS is a rectangle triangle, then of course we are going to use what? Trig ratios. We are going to be using trig ratios. Now, if we have a side, if we have an angle there, and then obviously this side is going to be opposite, and then this side is adjacent. because this side is going to be opposite, and then this side of PD is our adjacent. Then now we are going to use what? Tan, because it's only tan under trig ratio that has opposite and adjacent, because we cannot be able to use what? Sine. If we use sine, what is going to happen? We are going to have two unknown. We don't have an opposite. We don't also have what? We don't have the hypotenuse side, right? Hence we used what? Tan. Then we can see that we're having tan 32 degrees equals to SD over 70. Then the second step, what you have to do, then you're going to cross multiply. Then after you have done our cross multiply, then SD equals to 70 tan 32 degrees. All right. Then thereafter, you just press your calculator there. Then your answer is going to be 43,74. And then when you write it to the nearest meter, then it's going to give us what? 44 meter. So that's how you should calculate a side. Now we are having side DS or SD. And the second question that we have to calculate is ST. Let's go and look for ST. This is our ST. Can you see that? This is our ST. Now, let's see on how do we go about it. All right. From the scenario that we were given, it was very clear that they said SD equals to what? SD equals to ST. Then now, remember earlier on, we have just calculated what? SD, which is 44. Now, if that is the case, then also DT or TD is equals to 44 meter, right? Then thereafter, because now we're in this triangle of SDT, we're having two sides and one angle, and this angle is between those given side. Then remember earlier on we touched on the conditions, and then you remember very well this condition, it was under what? Under cosine rule. So obviously on this one, you're going to use the cosine rule to calculate this side of ST. Okay. Now, and then thereafter, you're going to write the standard equation. As you can see on the screen that we're having that standard, which is D, small d. And then we can, remember earlier on, I also touched on this one. If you have an angle there, which is D, then the opposite sides of this angle is going to be small d. All right. It's going to be small d. Then we're going to create that equation there. You can see small t. You can see there we have t, angle t, and a side which is opposite to this angle is going to be small t. The same applies with what? With S. All right. Then the second step, you just substitute there. Remember, small t is 44. It's the same as what? With small s, it's also 44. Then after substituting, you just press your calculator there. Then you're going to get this big number there, which is 5629,85. And then, my dear learners, I just want to advise you that before you reach to the final answer, don't round off anything, write everything. Write that answer that you are getting from the calculator as it is, and then you only round off when you reach the final answer. Now, we are having what? ST squared. But remember, we're not looking for ST squared, but we are in need of what? In need of ST. Then we're going to, we have to get rid of this exponent 2 here by doing what? Putting square root both sides. Then let's see. All right. Now, after putting square root both sides, then the answer that we are having is 75 meters, right? It's 75 meters. Then that's how you should calculate the distance of ST. Now, the last point or the last question, it says we should calculate the area of triangle SDT. Let's go and look for SDT. SDT is this triangle that we've been doing. And then let me just erase this so that you can be able to see. All right, let me just erase this one. Okay, now let's see on how do we calculate the area. And then remember, we also touch the condition for area, what a triangle should have for you to be able to calculate the area. One, that condition is only one condition that we're having. We must have two sides and one angle, and that angle must be between those two given sides. And of course, we have that. Remember, we've calculated side SD. We also have DT, right? It was 44. Remember, it was 44 meters. Then we also have that angle, which is 117 degrees between those two given sides. Then it's possible for us to calculate the area of triangle SDT. Then let's see on how do we do that. You first write your standard equation for area, which is half over 2 t small t and small s sine d, right? Then of course, remember what I said about this angle here, angle S, and then the side opposite to that angle is going to be small s. The same applies with this t, is going to be small t. Then we just substitute, and then we're having 44, and then the other one is sine 117. And the answer that we're getting is 862.49 meters squared. Then remember, we calculate the area, so it must have that unit of meter squared, right? If we don't have any unit, remember we're using what we're using, unit squared, to show that we are calculating the area. Because during exam, if you don't put this unit of meter squared, you might not get the mark for that answer there, because of you missed the units. Now let's continue. Let's continue and see what we are having. Example 3. All right. Okay. Now let's see what we are having from our scenario there. It says the diagram below represents a person standing at point A there. You can see there's point A up there on the top of the building AB, which is 50 meters high. He observed the two buses C and D. You can see D, there is a bus there, and C, a bus that are on the same horizontal plane as B. The angle of elevation of A from C is 55 degrees, and the angle of elevation of A from D is 55 degrees as well. And then C angle AD equals to 65 degrees. So that's what we are having from our scenario. And then let's go and try to understand on how do we answer the question. The first question says calculate the length of AC to the nearest meter. Let's go and look for AC. You can see that this is this AC, right? And then AC is attached to two triangles, which is ABC as well as ADC, right? Now for us to be able to calculate this side of AC, then of course we're going to use what? This triangle of ABC, because we're having an angle there and also have a side there. It's going to be possible for us to calculate using that triangle. Okay, and then of course we are going to use what? Sine. Under trig ratio, we're going to use sine because we have an angle, and the opposite side, which is 50 there, then this side that we are calculating is hypotenuse. Then of course we're going to use sine. Then after substituting there, then you're going to do cross multiply, and then just press your calculator, and then our answer is 61 meters. All right, 61 meters. And then the other questions say calculate the distance to the nearest meter between the two buses, meaning we are in need of this distance there, this distance. All right, let's see how do we do that. Now first, AD equals 61 meter. We're still going to use the trig ratio of sine, meaning for us to be able to calculate this side of DC, we also have to calculate side AD. Then we're going to use the same process that we have used when we are calculating the first question there. You can see that in this triangle ABD, we have angle which is 55 and the side is 50. Hence, the distance of AC equals to distance of AD, right? Then we are now writing the formula there for cosine. Why? Because now we are having what? We are having two sides and angle which is between those two given sides, right? Then we're going to use sine rule to calculate that. And then what you have to do with this one, then we substitute. After you have substitute, then you just press your calculator. Just put everything on your calculator, my dear learners, and then you write everything that is on that calculator. Thereafter, the fourth step, then we have to get rid of this 2 there. Then we're going to put square root both sides. Then we're going to put square root both sides. Then the last point there, the answer is 66 meters, right? 66 meters. All right. Now, I think we've done calculating that side DC. Then the distance between the two buses is 66 meters. And the example 4 is still on 2D problems. A, B, and L are points in the same horizontal plane, and HL is the vertical plane on the length 3 meters, and then AL equals to 5,2 meters, and then A angle LB equals to 113 degrees, and the angle of elevation of H from B is 40 degrees. All right. And then the first question says, calculate the length of LB. Where is LB? You can see there's LB there. We're calculating this angle LB. And then an LB is part of this triangle ALB as well as HLB. And then which triangle to use? Let's see. Of course, we are going to use this triangle of HLB because we're having what? We're having angle there and there and the side. Because this is a right angle triangle, then we're going to use trig ratio of tan. And then we're going to substitute. Then after that, you cross multiply. Then you press your calculator. And then you are now having 3,6 meters. All right, it's quite simple. The second question, hence or otherwise calculate the length of AB. Calculate the length of AB. Let's calculate the length of AB. Where is AB? This is AB, right? Now we have to check what we are having. We're having side AL, we're having also side LB, and then angle is between the two given side. Meaning in this one, we're going to use what? Cosine rule. We're going to use cosine rule. And then you write the formula for cosine rule. This is the formula for cosine rule. And the second step, you just substitute. And then you just press your calculator, put everything on your calculator there. And then this is what you're going to obtain. And then again, my learners, please don't round off before you reach the final answer. All right, now let's get rid of this squared there. Then we're going to put square root both sides. And then this is what we are having now after putting the square root. And then that length is 7,4 meters. That length is 7.4 meters. Now calculate the area of triangle ABL. ABL. Now it's going to be possible for us to calculate the area. Why? Because now we're having a side AL and a side LB and angle between those given side, because it's one of the condition of what is condition of area rule. You must have two side and one angle which is between the two given side. Then you just try the formula for area. The area of the formula for area there. Thereafter, the second step, you substitute, then you press your calculator. It's very important. I will always repeat unit square to show that we are calculating for area. Now let's see what we the diagram at point A on top. All right, now let's try to answer this question, which is if the area of the triangle is supposed to be area, here's the typing error. If the area of triangle ABDC is 553 meters squared, calculate the size of triangle of B angle DC. Let's go and look for B angle DC. B angle DC, meaning we are calculating, or we need to calculate this angle there. But this time we are not going to calculate the area because we are having an area. Then we're going to use that area to calculate that side. Then let's see on how do we do that. First, we have to determine the length of what? BD, because we don't have the length of BD. Let's see on how do we do that. And then of course we're going to use the trig ratio, because this side is attached to this triangle. I mean right angle triangle ABD. Then we're going to use what? Tan. Then you cross multiply, and then you just press your calculator. Then now we are having what? You are having 35 meters. And then now let's see on how do we answer that question. Then you're going to write the area formula, which is DC. We have DC, and then of course BD sine B angle D. And then you just put the area that we are having and the sides as well. And then we have what? We are having side DC, which is 66. And then we have the side BD, which is 35. Then the third step, then we're going to do, we're going to divide both sides. Then we're going to divide both sides. This half 66 times 35. All right. Thereafter, then you're going to divide with side so that you can be able to calculate the angle. Then you're going to press shift on your calculator, shift side, then you press this fraction there, all right? And then let's see what is going to be our angle. Then our angle is going to be 29.17 degrees. So that's how you should calculate what? That angle D, okay? All right. Thank you very much. for being with me on this lesson. My dear learners, I have got message for you before I can close everything. And then that says, if you wait for perfect conditions, you will never get anything done. Now, let us make sure that we prepare ourselves thoroughly before we go and write your trial exam or the final examination. All right. And then thank you very much. Have a nice day.